Okay, so this is lesson 2, not lesson 2.1, just lesson 2. More on particle motion. We're going to use a graphing calculator to answer each of the following questions about a particle that moves along a horizontal line so that its position for any time t greater than or equal to 0 is given by this function. When is the particle moving right? Well, we need to find velocity in order to know direction. So remember, velocity function will tell you direction. It will also tell you speed. So velocity is the derivative of position. So 3t squared minus 10t plus 2. All right, we're going to graph that on a graphing calculator. So please join in with me. So I need to graph by going diamond F1. Everyone needs to be able to graph an equation. The AP calculus test is very careful to make sure that you having a fancy calculator can actually do calculus like ours can doesn't give you an advantage. It does give you a little advantage in that on a problem like this, we could have told it to take the derivative for us. But typically, you should only have to do a numeric derivative, so we'll wait and do it that way. All right, we're going to type in this equation right here. So we'll do 3x squared minus 10x plus 2. Notice that I use x, not t. And then I will graph it. I don't think it'll work. All right, well, I've obviously been doing something with my graph that's got a weird, so it's diamond F3. It's got a weird looking picture. Not going to worry about that. Actually, it looks like it's not that bad. But let's go to a normal zoom. So looking at these menus here, these tell you what your top buttons become. So F2 zoom, and I just want to do standard, which is 6. Most of the time, we're just going to use our zoom. Occasionally, we'll have to do other things. All right, I can see now that my velocity function changes sign from positive to negative right here and right here. So we're going to find that moment. Okay? And the way we do it, yes, you could type this into a solve feature. Don't do it, because oftentimes it will freeze the calculator. They want you to use a graph. So we're going to say F5 because we're going to do math. Everybody do this with me. And we're finding where it crosses the x-axis. That is a 0, so press 2. And you have to tell it a lower bound and an upper bound. And the lower bound and upper bound are x coordinates, just like intervals. They're showing you the y coordinate simply so you know that you are switching from a positive to a negative. I want to make sure that changes from positive to negative. So I'll just hit enter there. And then the upper bound means I'm pressing to the right until I see the y coordinates get negative. And press enter. It should highlight the one that it finds. That's the x coordinate I want. I'll simply document it like this. V of t equals 0 at t equals 0.213. 4. 0.214. Let's solve for the next 0. F5, 2, lower bound, upper bound. You've got to practice finding the 0 with your calculator. You have to practice it. 3.120. Notice that this is not exactly 0, but by scientific notation, you can tell that that's 0.11 zeros and then a 1. So it is basically 0. Okay. From the graph, we can clearly see that velocity is negative in between those points and positive to their left and right. So we are moving right from 0 to 0.214 and 3.120 to infinity. because v of t is positive. We're moving left from 0.214 to 3.120 because v of t is negative. It's as simple as that. All right. Okay, let's find the distance traveled by the particle from 0 to 5. So to find the distance traveled, displacement, I would just do s of 5 minus s of 0 to find the change in position. But for distance, I've got to calculate it at 3 different places. I've got to calculate it from 0 to the first time it changes direction, then from then to the second time, and then from then to 5. So we'll do s of 0.214 minus s of 0, the absolute value, plus the absolute value of s of 3.120, and that's going to be, this one's going to be a negative interval here because it was moving to the left. Plus we'll do the change in position from 5 to 3.120. All right, so we'll do that. So I'll go back to my home screen on my calculator. And I want to show you something. We can actually say y1. Okay, because our y value, y1, is this equation here, and we've already got it in there. Well, that's my velocity, actually. Never mind. Anyway, that was a cool thing, but I guess it doesn't matter now. Doesn't help us here. All right, we're going to use position. So we'll do t cubed minus 5t squared plus 2t minus 3 such that t is equal to 0.214. That's one way you can do it. I'm going to show you one other way I can do this, the way I actually prefer to do this. It would be to type that into an equation as well. See, I can type that in to y2. I can say x cubed minus 5x squared plus 2x minus 3. So I can do that, and then I've got a y2, and I can do what I wanted to do earlier and say y2 of 0.214, and then I can say y2 of 0. And that's a nice way to do that, right? Should be positive, though. Unless I mistyped it in. Oh, I sure did. I've got a 2 here. All right, so I'll go back and do that one more time. And that's 0.209. There is one other way I can do this, which is probably my absolute favorite way, and that is to go to define. So if you go to F4 menu in the home screen, other, you can say define. And I can actually say, like, alpha s, which is the button 3, of t equals t cubed minus 5t squared plus 2t minus 3, and it'll say done. And then I can actually say stuff like alpha s of 0.214 minus alpha s of 0, and it works really well. And then I can just go in here and change this to 3.120 minus 0.214. So that, but I need the absolute value, so that's plus 12.269. And then finally we'll do s of 5 minus s of 3.120. So those are pretty much the three best ways to do that. You can use the such that key like we did earlier. You can use the Y2, which I think is what most of my students kind of use, the Y1, Y2, stuff like that. Or you can actually define a function. But I do like to use at least define function or the Y2 because that allows me to type it in like that instead of get one, get the other, and then subtract. So we can see that the total distance traveled was 34.539. Okay, find the intervals where the speed is increasing. Okay, so we need to find acceleration if we're going to find out when speed is increasing. If they asked when velocity was increasing, I would simply take the acceleration and find when it's positive. But this is going to be a little bit more interesting. So we'll find the derivative of velocity. So that's a 6t minus 10. Okay. And we can graph it if we like. So 6x minus 10. And then we can actually see the two. We know speed is increasing if they are both negative or both positive. The zero of the acceleration, we could probably find that more easily just by doing algebra, but I wanted to show you up and down on the left arrow to switch up and down arrows, to switch between the two curves. And I'll just go to the left of the zero and to the right of the zero, and we'll see it's 0.1667. So a of t equals 0 at t equals 1.667. And then even with the graph, I still prefer to make a number line. We can see that we have endpoint at 0 at 1.667. The acceleration changes from negative to positive. You can see on the graph it was negative, then positive. The velocity changes at 0.214 from positive to negative, and then changes back at 3.120 to positive again. Where the signs are the same is when this particle is speeding up. So our particle's speed is increasing on the interval from 0.214 to 1.667. That's because both velocity and acceleration are negative. And then again, from 3.120 to infinity, because v of t and a of t have the same sign. All right, so if you would please practice 2.1. Okay, for practice 2.1, a particle moves along the x-axis so that any time t greater than or equal its velocity is given that value. We want the acceleration at time t equals 4. So what we're going to do is we're going to evaluate v prime of 4 because the derivative of velocity is acceleration. And it's important to me that you practice typing that in on a calculator. So the way that you find derivative is second 8 or under the calculus menu, differentiate. Then you type in your equation. And I highly recommend you do not use implied multiply for things like cosine and stuff like that. Just be real careful with it. You can use it there, but just be careful. All right, then you have to hit comma, and you have to say what to differentiate with respect to. Put the variable, close parentheses, that's the derivative. Check the pretty print to make sure that it's exactly what you wanted. But if you want the derivative at a specific value, you have to say such that t equals 4. And so we get the value to be 1.633. So that's the acceleration at time t equals 4. Okay, an object moves along a straight line so that at any time t greater than or equal to 0. Sorry, typo there. It should be its position is given by s of t equals 2 sine 3t. What is the distance traveled by the particle from t equals 0 until the first time it stops? So to know when it stops, we have to know velocity. So velocity is going to be 6 cosine 3t. I did the chain rule and multiplied the 3 times 2. So this is going to equal 0 when? Well, let's find out. That'll be when cosine is equal to 0, which is at the first time cosine equals 0 is pi over 2. So that implies that t equals pi over 6. So t equals pi over 6 is the first time this particle will stop and actually change direction. So to find the distance, we simply need to evaluate s of pi over 6 minus s of 0. So plugging in pi over 6, I get sine of pi over 2 times 2. Sine of pi over 2 is 1, times 2 is 2. S of 0, the sine of 0 is 0. So the value is simply 2. Next we're asked, is the particle speeding up or slowing down at t equals pi over 4? First, let's see if the velocity is positive or negative. So v of pi over 4. V of pi over 4 is 6 cosine of 3 pi over 4, because they have to multiply by 3. 3 pi over 4 is in quadrant 2, where cosine, an x value, is negative. So v of pi over 4 is a negative number. So the particle is moving backwards. Let's find acceleration. Our acceleration function would be 18, negative 18 sine of 3t. A of pi over 4 is a negative 18 sine of 3 pi over 4. Well, sine is positive in quadrant 2. So this is a negative times a positive number. So a of pi over 4 is also negative. So because v of pi over 4 and a of pi over 4 have the same sign, we know this particle is speeding up. All right, now I want you to do practice 2.3 and 2.4. Okay, a particle travels along a vertical line with its position y of t equal to negative 8t to the fourth minus 4t. This is a cubed, by the way, so be careful with that. It was a little typo. We're going to find the acceleration when the velocity is 0. So first we'll find the velocity, the derivative of position, negative 32 t cubed minus 12t squared plus 8t plus 30. Next we'll find acceleration. That's a negative 96t squared minus 24t plus 8. So we want to find the acceleration when velocity is 0. So we'll graph the velocity equation. So negative 32x squared, x cubed, minus 12x squared plus 8x plus 30. And we'll graph, and we'll see where it crosses the x-axis. Okay, so it's looking like it's right there. Usually they give you a pretty good window to set. You'd have to kind of like zoom out more to see that this never comes back. But for now, that's good enough to see that that's where it crosses. So we'll say F5 for math. We'll get a 0. And that's good enough right there. And then as soon as it goes negative, that's good enough. So point. You know what I realized? I think I did the wrong thing. I did the velocity, and I was supposed to do acceleration. Well, that's okay. It allows me to show you how to turn off a graph. F4 is the check mark. Turn it off. We're supposed to find... No. That was right. I was looking at the... I was thinking about it. I think I was thinking about a homework problem. All right. Well, we found the value, right? What was that value that v of t equaled 0 at? Oh, I know somebody remembers it. What was the t value? So F5, that's fine. Give us a chance to review it again. F5, 0 needs to be right there, and then right there. 0.943. So then we'll say A of 0.943 is equal to, and I'll just use the such that key on this one. So I'll say negative 96 times 0.943 squared minus 24 times 0.943 plus 8. Well, that's suspicious. No, they are not. It is not okay. They need to be. They need to be within one decimal point, up or down. So if we're disagreeing, one of us is wrong. So let's. So I. Did we type in the same derivative? Yeah, that's what I'm talking about. You've got to practice, because if you're not having this experience where you're not getting the same answer, it's going to happen to you on a test. And yeah, it's wrong. If the answer is 0.794 and you give me 0.792, it's wrong. So you've got to be accurate. F5, math, 0. Okay, so this one's a tough one. You may want to change your bounds a little bit so you can see more of it, but you just got to get that blinking cursor above it, because I'm to the left and I have to press to the right, and I can't even see anymore. But look how the y coordinate's negative, so it's good enough. 0.943. Your y coordinates have to change from signs, or else you're not encompassing the 0 in that bound. No,